Today I want to talk about Amazon SQS, which stands for Simple Queue Service, SQS, and what it's trying to solve. Clear? So I give you an analogy of I have a cow shed, and this is the where you want to take all your cows for parasite. That cattle dip. So you have all your cows here, and you're trying to get them here. So if you start chasing them through, others will try to run the other side, others here, because cows don't like getting wet. So you're going to use way more energy trying to find these and bringing them back. Yeah. How would you do that again? So I would solve this by, for example, this is my cow shed basically. I'd make sure I divide that into two, and then I have all my cows staying on this other side. And what I'd do is I'd put my cattle dip in the middle of the ranch, and then I would force all my cows to go through this on the other side, so that by the time all my cows on the other side, I know all of them actually went through the cattle dip, so they were actually treated. That means everything was consumed. So by putting this in the middle, I'm basically solving the problem of having to run away to look for other cows, that might not get might not get treated. I might miss some of them. And that is how SQS service basically works. So that, for example, if I have a front-end application and let's say logic, then I have a database application, and then this is posting request here, and then at some point it's Black Friday and everybody is trying to purchase at the same time, and there is so many requests that this is overwhelmed and cannot process them at the same time. So how would you fix that? You bring in something in the middle here. This is supposed to be like a traffic stop, slowing them down enough so that this can process the messages that it has, and then request to process these. So this is SQS, Simple Queue Service. Yeah, so you have a front-end application, you have a database, and then you have SQS in the middle. So basically what you do, if you have all 5,000 requests per second, they all go in here and then they are queued. And then when this has processed all the messages it has, it will poll for this particular one. Polling is the process of consuming. So we have a consumer here, we have a producer here. This produces the message, sends it to the queue. The queue then it sits in a queue, and then the consumer can decide when it actually wants to do this. Then up to some point we have what we call a DLQ. DLQ stands for a dead letter queue. So basically, if you have some messages that were sent and there is a problem with the messages, they cannot be consumed or processed. Maybe there is a problem with the format of data. You will send those to a DLQ until you figure out why this cannot be sent. So this stands for a dead letter queue. So let's do that in writing. So we're not going to do it in code. We're just going to do it simply. So this is Simple Queue Service. This is Simple Queue Service. So this is a Simple Queue Service. So SQS in short. So you're going to create a queue. So we have two, FIFO and standard. FIFO stands for fast in, fast out. So this is what we call exactly one processing, fast in, fast out delivery. So whatever goes in fast goes out fast. Standard queue is technically not a queue. Yeah. So let me see. It's technically not a queue. So if you come here, for example, you have this sending the message, this receiving the message, and then we basically have an SQS. When this goes into an SQS, you realize it's just not one queue. It can there are several queues inside this one queue that they can that they all can go through. You basically get, so there is queues within the one queue. So FIFO makes sure exactly everything is in order. FIFO is basically one queue. Whatever goes in goes out first. But in a standard queue, when you go inside the first queue, there are other queues so that you join which queue. So it's like you join which line is faster. So if you find 50 people in this line, then you join the one that has 20 people. That's basically in layman's language, basically in layman's terms. So if you come here, I'm going to say I'm going to say queue. And then visibility timeout. So what is visibility timeout? So visibility timeout, when you have a message being processed, you make sure you want to preserve, I don't know, is it atomicity or whatever. So you want to make sure that you cannot process one message that a consumer, if you have several consumers, you want to make sure that two consumers cannot process the same message at the same time. So when you have 30 visibility timeout, you say when you have 30. When you have, let's say, 30 seconds for visibility timeout, then when that message is being consumed, nothing else can actually see it. So that is visibility time. You can set it to whatever second you want. Retention period is how long do you want it to stay in queue. You can say you want it to stay in queue for 1 hour. Delivery, let's say, is 0. And then maximum message size is 256 KB. Server side encryption, enable that by default. And then you have policies. So you decide who do you want to, who can send messages to that queue. You can specifically give a specific Amazon resource name for a particular user, or you say the queue owner. Define who can receive the message there, and then the policy is here. If you have more advanced policies and you want to, if you want to modify that, you can do that there. And then we have a DLQ. Set this. So if you want to set this to receive undeliverable messages, you can enable that. You can enable basically you can basically enable DLQ if you have for messages that are undeliverable, so that you can check what's up with them. We don't need that for this. So you can make a name tag. You can give a name tag. You can give a name tag to that, and then you can say Kefa right. We can say Kefa. I can say that, and then create queue. There you go. So this is what you call a URL. So this is the URL that you hit when an application wants to send things to the queue. This is the URL that the application will hit. The application will hit this particular URL to send messages here. So you might use it. So now let's see how things happen. So we can come here and send and receive message. So when I say send message, this is just a test. So message can be anything: transaction details, or I just say hello, what's up. So usually application send details of transaction. So we're just going to say hello, what's up, and then we're going to send message. So when you send message, this message is now sent into a queue. So sent into a queue, the message is already in queue, and this one was processing another transaction. So when it's done with the transaction, what it's going to do, it's going to come to the queue and then poll. So it's going to request for another message to that. So that is what we call polling. So when you come here, you can edit polling results. You can say what is the duration for polling. I've said 5 seconds and saved. So I come here and just say poll for message. So poll is look into the queue and see if you can find a message. So if I click here, I see there's a message that say hello, what's up, and that is how it's done. So now this is basic graphical user interface. So now you can implement it in your own way using SDK. So in this article that I wrote here, okay, so I also gave creating this using Amazon CloudFormation and Terraform equivalent. So if you want to create, let me see, sorry, click on if you got one already, Lambda permissions. So let's see. So you come here, for example, you can send this using code. So I can simply copy here this and say here, and let's probably say we want to do Lambda. So we want to send this via code. So let's open Lambda, AWS Lambda. So we want to use code. I don't know, we could already stop there, because these things that you actually know. We can already actually stop there. I don't know why I'm going